हाँ वो ठीक है fine, I know. So I will check this YouTube chat box, right? Okay, and my yeah okay. Very good afternoon. I welcome you all to this session of Engines and Gas Turbine, precisely the live session, and I request all the students who are registered with this course to post your question in the chat box, and I will try to discuss them sequentially. I can understand that you all have raised questions already in the discussion forum, but still the session is kept for a live discussion of those questions. So I request the students who have joined this program to post your question in the chat box so that we can take them for further discussion. You know very well that the session is limited to only 1 hour. So I request you all to post your question in the chat box, and I will discuss them sequentially and systematically. The course Engines and Gas Turbine is an important core course to the students, I should say the undergraduate students of mechanical engineering, chemical engineering, electrical engineering, automobile engineering, and power plant engineering. So in this course, there are several modules. In a few modules, we have discussed about several aspects of internal combustion engines, while in the remaining modules of this course, my colleague Professor Vinay Kulkarni has discussed about gas turbine part. I request you all to post your questions if you have any in the chat box so that we can take them for further discussion. In the IC engine module of this course, we have discussed several topics, including thermodynamical aspects, thermodynamic cycles. In addition to engine classification, engine nomenclature, combustion of both SI and CI engines. Though I have discussed this particular aspect, I should say combustion is an important aspect of internal combustion engine or engine, but I have briefly discussed about the combustion part. Then we have also talked about the ignition, fuel selection, and then we have also discussed about thermal management, focusing on the coolant typically used in internal combustion engine. So I request the students who are attending the session to post your question in the chat box so that we can start our discussion without further delay. You know very well that the session is limited to only 1 hour. So we have to discuss the questions that you have already within this stipulated period. Already you have raised several questions in the discussion forum. We have tried our best to reply to those questions, Even then, if you have any further question, kindly post your question in the chat box. Internal combustion engine is an important topic of internal combustion engine and gas turbine is an important subject, I should say, of many undergraduate courses, and in particular those who are very much interested in automobile, internal combustion engine will play an important role to understand and also to explore more into this subject. In this basic course, since this course is mainly designed for the undergraduate students, we have discussed several topics, as I said, starting from engine classification, engine nomenclature, then thermodynamic cycles. We have also discussed about the necessity of having a thorough understanding of thermal or thermodynamic cycles. Those are used to describe the processes. Those are occurring inside the engine cylinder in a cyclic manner, essentially to understand the engine performance. Then we have also discussed about fuel injection system. We have also discussed about fuel types, and then most importantly we have briefly discussed about both SI and CI engines combustion. Finally, we have also discussed about the thermal management, because when combustion occurs, a significant amount of energy in the form of heat is generated, and a substantial part of energy needs to be transferred to the coolant, essentially to save several parts of internal combustion engine. So we have discussed about the types of coolant typically used and also the heat balance. Together with these topics, I have also tried to solve a few numerical problems illustrating the conceptual part that I have discussed in the class. I request you all to post your question in the chat box, because understanding of this course or subject will be very much important to know more about automobiles, to know more about design aspects of engine system altogether, and also gas turbine part. Gas turbines are also very much important because there are many captive power plants wherein gas turbines are used instead of steam turbine. On the other hand, a major application of gas turbine is aircraft field, so propulsion field. I believe my colleague Professor Vinay Kulkarni has thoroughly discussed about the gas turbine parts. If you have any questions from gas turbine part, I would suggest you all to post your question in the discussion forum, or even if you can write email directly to Professor Vinay Kulkarni, he will be happy to give answer to those questions. from the internal combustion engine part, if you have any question, I request you all to post your question in the chat box. This session is limited to only 1 hour. So if you post your question in the chat box, I would like to discuss all of them to the extent possible in this session. This session is purposefully kept to interact with the instructor of the respective subject. And if you have any doubt, if you need any clarification further for your better understanding, this is the right platform where you can interact with the instructor. I welcome you all to this session and kindly post your question in the chat box. Though the intuition is, because of electrical vehicle internal combustion engine will have an insignificant role to play, but I would like to tell you it is not the case, because for the heavy vehicles or even for the commercial vehicles, passenger vehicles, even till today, it is very much essential to design modern engines. When we talk about the design of modern engines, essentially we need to look into the efficiency or the performance of internal combustion engine. We all know that in an internal combustion engine, we need to supply fuel, and the stored energy within the fuel, which is the chemical energy, gets transformed into heat energy, and eventually that energy is further transformed into mechanical energy. So essentially, because of this heat generated out of the combustion, we can have continuous motion of the crank and connecting rod. So the most important part is we need to supply fuel. Because of scarcity of the fuel, also in another hand, we also need to look at the environmental pollution aspect as well. So it is not only the cost that we should be concerned, together with the cost associated with the fuel to be supplied to the engine for an efficient combustion, we also need to look at the combustion products which are not environment friendly. So together with these two important problematic issues, we need to think about modern engines, rather what should be the future of the internal combustion engine. What are the aspects should be taken into account while designing the internal combustion engine, rather modern internal combustion engine. So as I said you, the most important component that the designer should consider is the fuel economy. Fuel economy, you can understand that essentially we need to maximize the engine performance, because at the cost of fuel we are getting some work output. You have learned from basic thermodynamics course that heat and work, these two are two different forms of energy. So essentially, when you are supplying fuel, we are allowing that particular fuel to combust in the presence of air, and from this combustion process, the heat being generated, that is energy in the form of heat, will be converted to another form of energy, that is work. So we'll be getting work output at the shaft of the internal combustion engine. So at the cost of some input energy, we are going to have output energy in the form of work. So certainly, as you have learned from thermodynamics or second law of thermodynamics, we need to determine the efficiency. And while you are talking about efficiency, we have to think for its maximization. So our objective should be to get more work output, and if we need to achieve it, what should be the design strategy? Those are very important futuristic potential of internal combustion engine. Also, instead of conventional fuel, there are research groups, and the prime focus of those research groups is to explore the possibility of using non-conventional fuels. And then another important aspect is to consider the air pollution level. So design strategy should be to reduce the air pollution to the extent possible, so that an internal combustion engine can be utilized in different fields. So these two aspects are very important. If you need to know, or if anyone would like to design an internal combustion engine or internal combustion engines, the futuristic aspects should be to economize the fuel, which is equivalent to maximize the engine efficiency, and also to minimize or to reduce the air pollution level. So these aspects are very much important. And as I said, if you are really interested in this particular subject, then you must have basic understanding, and to have some understanding, I should say some conceptual understanding on this subject, the course Internal Combustion Engine and Gas Turbine is indeed a platform. So I request you all to go through several modules of this course. It is not only internal combustion engine, as I said you, that gas turbines are equally important for several practical applications, starting from power generation in captive power plant, and most importantly in aircraft or propulsion areas. So what are the fuels? What are the basic cycles used to describe the performance of gas turbine plant, together with some design modifications which are needed to be considered for the future design of gas turbine or gas turbine engines or gas turbine units. So all these aspects have been discussed in this course, and I hope you all will enjoy. Though the gas turbine part or the modules of the gas turbine part will be discussed at a later part of this course duration, I mean at a later part of this course content, but I hope you will enjoy. So let me tell you once again, this session is restricted to only 1 hour. If you have any questions from the parts or the modules already you have completed, I'm pretty sure that you had questions. You had raised those questions in the discussion forum, and we have tried our best to address those questions. Even then, if you are still having some questions to be discussed, kindly post your question in the chat box. As I said already, this live session is purposefully designed to have a live interaction with the instructor of a particular course. And if you need any clarification, if you have any doubt, all these doubts, further clarifications needed at your end will be discussed in this session. So I request you all to post your question in the chat box if you already have, or if you had these questions, I'm sure that you raised this question in the discussion forum, but you have listened to them, but still you need further explanation, further clarification. If that is the case, I request to those, kindly post your question in the chat box. This session is limited to only 1 hour, so I request you all to kindly post your question in the chat box so that I can start discussion on those questions systematically. Internal combustion engine and gas turbine is an important core course, and there are many institutes wherein these two parts, that is, or two modules, that is internal combustion engine and gas turbine, these two modules are included in the applied thermodynamics course. But let me tell you, certainly you will get brief idea about these two topics from the applied thermodynamics course, but the course internal combustion engine and gas turbine, wherein several aspects of engine classification, gas turbine classification, their operation, and also combustion, these aspects have been thoroughly discussed. So this is the course internal combustion engine and gas turbine, which is not a part of the applied thermodynamics course. So this course is a separate course exclusively designed for a thorough understanding or thorough discussion of several modules of these two components of applied thermal engineering. So I hope you all will enjoy this course, and already you have completed a few modules, and I'm sure that you have enjoyed. You had a few questions. I had seen all those questions. We have tried our best to give answer to those questions. If you are not still satisfied with the explanation or answer given to you, kindly post your question in this chat box and we can discuss them. We have crankshaft in internal combustion engine and we know working of that, but why it is camshaft other than only cam and roller mechanism? See, this is crank and engine shaft. This is not the cam follower mechanism. Perhaps you are confused with. So crank and connecting rod mechanism, so we will have a shaft and that shaft is connected to the engine cylinder through crank and connecting rod mechanism. This is not the cam follower mechanism. So you know that the basic purpose of having this mechanism is to convert the reciprocating motion of the piston into the rotary one. And if you can recall that, if you can recall the situation of a multi-cylinder engine, many times engines are equipped with multiple cylinders just to increase or enhance the power output. Question is, if it is a multi-cylinder engine, then the designer should ensure that when there will be power stroke in a particular cylinder, in other cylinders, ideal strokes will be there, just to sort out or minimize the energy fluctuation. Now question is, if we use camshaft, then we really won't be able to minimize the energy fluctuation to the level of our expectation. And as I said you, the purpose of having this mechanism is to convert the reciprocating motion into the complete rotary one. And that is why this crankshaft is there or connected to the internal combustion engine. I request the learners who are attending this session, and if you are having any questions, any doubts, or if you need any clarification, kindly raise your question. Kindly post your question in the chat box to be discussed now. In this context, I would like to tell you that this is not only the kind of platform wherein you can raise your question, but still you have the provision to email me the questions if you have any, and you still can raise your question in the discussion forum. So I would like to reiterate here that this particular session is designed only to have live interaction with the respective instructor or instructor of the respective courses, and you can interact with the instructor, you can clear your doubts. If you need clarification, this platform will help you. I request you all to post your question in the chat box so that we can take them up for discussion here in this live session. As I said you that one important part, that is conversion of energy. See, internal combustion engine is essentially a place wherein energy conversion takes place. Energy that is given or supplied into the engine cylinder is the chemical energy, which is remaining stored in the fuel itself. And there are several mechanisms integrated to this engine cylinder wherein we need to initiate combustion. And combustion is the process by which we get some energy from the stored energy in the fuel, and that energy is the heat energy. So energy in the form of heat which is produced should be again transformed into another form, that is work. Because from our basic thermodynamics or classical thermodynamics that is taught, or probably I'm very much sure that you all have studied this course, heat and work. Now, you all know that work is high grade energy and heat is low grade energy. So certainly the amount of heat which is available, or amount of energy which is available in the engine cylinder in the form of heat, that energy cannot be converted, in its equivalent form to be available at the shaft. So the question raised here was, why crankshaft? So now question is, the heat energy that we are getting should be converted to work, and to convert that we have crank and connecting rod mechanism. So we'll be getting mechanical energy, right? Because the crank will convert the reciprocating motion into the rotary one, so we'll be having continuous rotational motion. Certainly, as I said you, some part of energy which is produced inside the cylinder should be taken away by the coolant. That is an essential part or essential system of an internal combustion engine. That is a cooling system. Because if we do not have any cooling system, we won't be able to sustain several parts. Camshaft is only used for the valve mechanism. That's all, or some else need to know. See, camshaft, even I am telling you, this is not the camshaft. This is the crankshaft. So again, you are confused with. The camshaft is not used in the internal combustion engine, rather it is the crankshaft. So this part of energy which would be available at the crankshaft is essentially a small part of the energy which is produced. So the understanding that we have that heat is low grade energy and work is high grade energy is again getting substantiated from the engine operation. So I am telling you, the shaft which is used in the internal combustion engine is the crankshaft. You should have a crank and connecting rod mechanism. So see, let me tell you one thing. This crankshaft and camshaft, perhaps I can give you some hints. You need to have some mechanical energy to be available, and if you need to have, so again, designer is very much responsible to design the crank radius, shaft, all these things. So just to get whatever amount of energy is available at the crankshaft, that should be used, and again a substantial part of that energy is remaining stored in the flywheel. So all these things are very important to know. Mechanical linkage mechanisms, just to think about energy conversion. And if we need to run a substantial part of energy, or if the substantial part of energy is going to be utilized to overcome the frictional losses, again it would be very ill design. So all these aspects, considering all these aspects, it is the crankshaft, it is not the camshaft. So anyway, I'd like to request you all to post your question in the chat box if you have, very quickly, so that I can take them up for further discussion. Otherwise, if there is no more question, I would like to wrap up this session. What is the difference between internal engine and AC engine and SI engine? See, Mr. Protus, you are asking. So this is basically, I do not know whether your question is pertinent or not. SI engine is a type of IC engine. You are asking internal combustion engine and SI engine. So SI engine is a particular type of internal combustion engine. Internal combustion engine can be classified depending on the type of combustion, number of strokes, etc. That part I have discussed in the class. So IC engine is essentially an internal combustion engine. Why it is internal combustion? Because combustion takes place internal. It is not external combustion engine. Just to differentiate these types of engines from the external combustion engine, the name is IC engine. Whereas SI engine is basically a type of IC engine wherein the combustion takes place with the help of an external agent that is called spark plug, and hence the name is SI engine. Stoichiometric concept in engine, stoichiometric, that I told you, stoichiometric is, the word is chemically correct. Now the word stoichiometric I have introduced while I have discussed about the carburation part. So carburation, that basically carburetors are used to supply stoichiometric air fuel ratio, that is the chemically correct air fuel ratio. What would be the consequences if the air fuel ratio being supplied to the engine is not stoichiometric one? Either combustion would be too lean to sustain the flame, or combustion would be, or the mixture would be too lean, or mixture would be too rich. So we need to have chemically correct air fuel ratio. If it is not chemically correct air fuel ratio, it is not really possible to operate a particular engine always in the correct air fuel ratio, always at a correct air fuel ratio. So it is not possible to operate any particular engine always at a correct air fuel ratio, but we should have a specific range, and the engine should run in this, engine should operate at a with a specific air fuel ratio, and if that specific air fuel ratio falls within that range, it is okay. But now if it is beyond that particular range, then the mixture should be either too lean or too rich to sustain the flame. Which one produces more horsepower? It is, let me tell you one thing. Yeah, carburetor is eliminated from internal combustion engine. Is there any effect on engine performance? Let me tell you one thing. Yes, you are correct. Carburetors are almost obsolete nowadays, but carburetors are typically, we used to provide carburetor just to provide air, chemically correct air fuel ratio. But nowadays, because of so many sophisticated technology, I should say, electronically controlled unit and many other things, it is really possible to supply the air fuel ratio which is needed for a particular type of engine to deliver a well-defined load. Now, yes, another question was which one produces more horsepower? See, SI engines are typically, that having low compression ratio. If it is low compression ratio, then certainly the power produced by SI engines should be relatively less. But if we need to produce more power, which are indeed needed for the commercial vehicles, we need to go for compression ignition engines, wherein the compression ratio would be more and we can have more work output. So I would like to request you all to post your question quickly in the discussion forum. It is already 40 minutes. If there is no more question, I would like to wrap up this session, but still you will have a provision of raising your question in the discussion forum. I'm pretty sure that you will be learning many other modules, many other topics of this particular course, and you'll be having many more questions. Still, we'll be having live sessions. This is not only the live session and regular discussion forum. So you can raise your question in the discussion forum. You can write, you can email me the questions if you will be having at a later stage of this course, and I'll be happy to give you answer to those questions. I request you all, if you have any questions, to post your question in the chat box so that we can discuss them very quickly. This course is very important course. In particular, those who are interested, to pursue their careers with automobile industries, to them, this course will provide an adequate basis to understand several conceptual paradigms. So I request you all to post your question in the chat box. I request you all to go through several modules of this course carefully. And also, though I have tried to solve a few numerical problems in the class, because of time limitation, we could not solve many problems. But my suggestion would be to solve numerical problems, and solving numerical problems will certainly help you to understand the conceptual part very clearly. So I request you all to post your question in the chat box. I'd like to wait here for another 3 minutes. If there is no more question, I'd like to wrap up this session. If you have any question, what is magneto-ignition system? That I could not discuss this particular topic in the class, but ignition system very well. But why it is magneto, so you can understand it is magnetically actuated. So using magnetic field, several things can be done. So using magnetic actuation or magnetic field, if we can initiate the combustion, if we can ignite the fuel, that part is magneto-ignition. I'm very happy to know that you are really interested in this particular topic. Since I really didn't get enough time to discuss this particular part, if you have, or if you need to know more about it, if you have really interest, kindly email me. I'll send you material which will help you to understand this particular topic. So I request you all to post your question quickly in the chat box, because this session is limited to only 1 hour. And if we really do not get more questions, then I would like to wrap up the session for today, and there will be more live sessions. Still, you have regular basis discussion forum units, so you can post your question in therein also. And as I said, you still have the provision of sending me questions over emails, and I would like to, or I'd be happy to give you or address all those questions. So I request students, participants who are attending this session, and if you have any specific or valid questions, kindly post them in the chat box. Yeah, my email ID, you might get it from IIT Guwahati website. I am from IIT Guwahati Mechanical Engineering Department. In the institute website, you go to Mechanical Engineering Department, check the faculty list, you will get my email ID from there. So I can understand that there is no more questions from the students, those who have joined today this session. And then I would like to wrap up the session for today. And I may repeat here that you can again raise the question in the discussion forum, even from the topics that already you have completed. You will be learning several other topics at a later stage of this course. You will be having many more questions. So you are really, interested to discuss any questions, to know more clarification, kindly feel free to email me or kindly post your question in the discussion forum. I will certainly get you back with the solution, with the answer to those questions. I can understand that there are no more questions, and if you really do not have any more questions, yeah, so my email ID has been given over here. You can note it and you can email me. I will give you answer to the extent possible, and I will try my best to address all the questions I will be receiving. So let me conclude here. So this session, the live session for this course, IC Engines and Gas Turbine, which was scheduled today, I had joined this session to interact with you all. I have discussed a few questions. I'm very happy that you had a question, you had raised question, and you are still having a few questions. So with this, I would like to wrap up this session for today. And as I said, you feel free to contact me over email to discuss or to know more about this subject. Thank you.